Hello everyone. Let us now discuss how can we solve this problem. Count good triplets. So we are given with an array and three integers a, b and c. We need to find the number of good triplets. So a good triplet array of I, array of j, array of k is good if the following conditions are true. So I is greater than or equal to 0, j is greater than I, k is greater than I, and k is less than array dot size. So array of I minus array of j, the absolute difference, is less than or is equal to a. This is the second condition. Array of j minus array of k, absolute difference, is less than or is equal to b, and array of I minus array of k, the absolute difference is less than or is equal to k. So here mod x denotes the absolute value of x, return the number of good triplets. So if we look at this example 301197. So I'll do nothing like first, as I said, I can be here and the j can be greater than I. J can be greater than I. So k should be greater than j. So let us see whether the difference is less than or equal to a. So 3 minus 0 is 3. It is lesser than a. Now first condition is satisfied. And 0, 1. 1 minus 0 is 1, which is less than b. So it is satisfied. 3 minus 1 is 2, which is less than 3. So it is satisfied. Now I got 1 as the count of good triplets. Now I'll go to the next element 1, right? So 3 minus 0 is 3, which is lesser than 7. 0 minus 1 is also lesser than 2. 3 minus 1 is also lesser than 3. So this is another triplet. Now I am going to the next k, 9. 3 minus 0 is lesser than 7. 0 minus 9, 9 minus 0 is absolute difference is 9, which is not less than or equal to b. So we'll skip this. Now we go to k, greater than is equal to 7. 3 minus 0 is satisfied. 0 minus 7 is 7. So we skip this. Now j will be the next index and k will be at this index. Now I have 3 minus 1 is lesser than or equal to 7. 1 minus 1, the absolute difference is less than or equal to b. 3 and 1 absolute difference is less than or equal to c. So the count of good triplets are 3. Now let me go to the next element. 3 minus 1 is 3. 3 minus 1 is 2. It is lesser than or equal to 7. 1 minus 9 is 8, which is not less than or equal to b. So we'll skip this. Now let me go to 7. 3 minus 1 is 2, which is less than or equal to a. 1 minus 7 is 6. The absolute difference is 6, which is not less than or equal to b. So we'll skip this. Now I have j, the next element is here, and k, the next index is here. Now 3 minus 1 is 2, right? Which is less than or equal to 7. 1 minus 9 is 8, which is not less than or equal to b. So we'll skip this. Now 3 minus 1 is 2, the absolute difference is less than or equal to a. 1 minus 7, the absolute difference 6 is not less than or equal to b. So we'll skip this. Here we go to the next index. Here 3 minus 9 is 6, which is less than or equal to a. 9 minus 7 is 2, which is less than or equal to 2. 3 and 7, the absolute difference is 4, which is not less than or equal to c. Now I'll take the next index for I, and j will be at this index, and we need to find the next element, just the next element. 0 and 1 difference is less than or equal to 7. 1 minus 1 difference is 1, which is less than or equal to b. 1 and 0, the difference is 1, so it is less than or equal to c. I will return 4 at the last. So what I am doing is just a brute force of for int I is equal to 0, I is less than n, j should be I plus 1, k is equal to j plus 1. But I can optimize this even better if I have checked whether array of I minus array of j. If this condition is satisfied, then only I go to the uh, third loop. So k the loop with uh, k index. So this is how you solve this problem. If you like this video, do share it to your friends and do subscribe to my channel. Thank you.